In the previous lectures, you have seen how you have derived a test bench that is based on pure Systemverilog features and how you have converted that test bench into a class-based test bench. Now you are going to see how you can convert that class-based test bench into a UVM-based test bench. Before converting the test bench, we will just refresh a generic structure of a UVM-based test bench. So this is the general outline of a UVM-based test bench. Here is your DUT and the whole red is your UVM-based test bench component, and both UVM-based test bench and DUT will be sitting in a top-level test module or something. And within your UVM-based components, the top level is a UVM test. Within the UVM test, you will instantiate one or more UVM environments, and different environments will consist of different agents within that. And each agent will be acting on a particular virtual interface in the DUT or a particular interface in the DUT, and a handle of that DUT interface will be given to this agent through a virtual handle. Also, your UVM test will start one or more sequences, UVM sequences, which will internally generate multiple transactions and send those transactions into the agents. Remember that every sequence will be starting within a sequencer that is sitting within an agent. Now, at this point, if you don't understand this completely, don't worry. Go ahead and just follow each and every process of converting the original test bench into the final UVM-based test bench. Correlate your final test bench into this diagram. Now, this is a pattern we follow to write the UVM-based test bench. So instead of writing a simple hello world kind of program in UVM, I'm going to write the complete test bench that is equivalent to the first test bench that you have seen in previous sessions. Therefore, you will be writing each and every component that is required for the UVM-based test bench. So first, we will write a UVM-based transaction. Then you will write UVM sequences. Then we will go into the environment side. So first, we will write an agent. So in the agent, you need to have a sequencer, driver, and monitor, which we will individually write. And after writing an agent, you will be writing a UVM environment, and finally you will be writing a UVM test. Also, you will see how these are connected together, how a stimulus will actually inject something into the DUT. Now, if you correlate this into our AXI example, you will be having your DUT will be having only one single interface. Therefore, you need to write only a single UVM agent and a single environment which is instantiating that UVM agent. And also, to keep the test very simple, we'll be writing only a simple UVM-based sequence which will send 10 random transactions into the DUT.